In this lesson, we will explore the various properties of the Arnold Standard Surface shader. Arnold provides a variety of presets that allow you to apply materials quickly. However, it can be difficult for beginners to understand what each parameter does and how it works. In this lesson, we will adjust the material parameters directly to learn their underlying principles. First, create an Arnold dome light. A dome light is used for image-based lighting with HDR images. HDR images contain high dynamic range lighting information from real-world environments. You can download free HDR images from HDRI Haven. Save the desired HDR image in your project's source images folder. Then connect the HDR image to the dome light's color slot. Render the scene in render view to see the lighting applied. Now, let us examine the material properties. I have assigned a different aiStandardSurface material to each object. First, select the cup and open the base section. The base weight determines how much the base color contributes to the material. Lowering this value makes the surface appear darker. The base color represents the intrinsic color of the object. It is the color seen from diffuse reflection on the surface. Increasing diffuse roughness spreads the diffuse reflection more broadly and softly. This parameter is useful for materials such as concrete or fine sand. The specular section controls highlights and environmental reflections. For non-metals, the specular weight is typically set to 1 and the color to white. This is because non-metals reflect the color of the surrounding light. Specular roughness determines how sharp or blurry the reflections appear. Next, let us examine the bird sculpture. Metalness is the key parameter that determines whether a material behaves as a metal or a non-metal. In practice, it is usually set to either 0 or 1. Setting the value to 1 makes the material behave like a metal. A roughness value of 0 produces mirror-like reflections. I will set the roughness to about 0.3. When metalness is set to 1, making the material a true metal, the IOR parameter is no longer used. Anisotropy stretches the highlights along a specific direction. It is commonly increased to create brushed metals such as cookware or tumblers. The direction can be adjusted with the rotation parameter. Next, select the vase. Transmission is used to create transparent materials. Its default value is 0, but it should be increased when creating glass. For refractive materials such as glass and gemstones, the IOR is important. IOR is a physical value that describes how much light bends when it enters or leaves a material. You can easily find IOR values for various materials online. Arnold shaders follow the law of energy conservation used in physically based rendering. As a result, increasing one component naturally reduces the contribution of others. To create colored glass, adjust the transmission color. Depth represents the distance light must travel within the material for the transmission color to fully develop. A smaller value causes even thin glass to appear strongly colored. A larger value produces coloration only in deeper regions, like thick ice. For the next object, increase the transmission and examine scatter. Scatter describes light being diffused by particles within a transparent material. If the scatter color is black, no scattering occurs. Adding color creates a cloudy or murky appearance. It is useful for materials such as cloudy water, juice, colored gemstones, and frosted glass. Scatter anisotropy controls the preferred direction of the scattered light. A value of 0 scatters light uniformly in all directions. Positive values favor scattering in the forward direction. Negative values favor backward scattering. The dispersion AB parameter controls the strength of the prism effect as light passes through glass. A value of 0 produces no dispersion, while higher values create more pronounced rainbow colors, as seen in diamonds. Transmission extra roughness blurs only the light traveling through the material, independently of the surface reflections. It is useful for materials with a glossy surface and a cloudy interior. Next, select the candle and examine the subsurface section. Subsurface scattering occurs when light enters a surface, scatters inside, and exits again. It is commonly used for skin, candles, and milk. The color parameter determines the color of the scattered light. Radius controls how far light travels within the material. Adjusting the RGB channels individually allows you to create effects such as the reddish glow of skin. Scale is a multiplier applied to the radius values. It is used to adjust the overall scattering depth according to the size of the model. The random walk method is commonly used because it provides accurate and smooth results. Anisotropy controls the directionality of the internal scattering. Now let us examine sheen on a fabric material. Sheen adds the soft edge highlights characteristic of fabrics such as velvet and satin. Emission makes the object emit its own light. Increasing the weight makes the object brighter and allows it to act as a light source. Thin film defines the thickness of a thin film layer in nanometers. Enabling thin-walled in the geometry section is useful for soap bubbles and thin glass shells. Changing this value alters the iridescent interference colors. This concludes our overview of the most commonly used parameters. You can now start with presets and fine-tune only the parameters you need. Finally, let us examine the dome light. You can change the lighting direction by rotating the dome light. You can adjust the brightness by changing the intensity or exposure. Setting the camera visibility to 0 hides the HDR background from the camera. By adjusting the visibility options below, you can see that the dome light no longer contributes to the corresponding ray types. Thank you for watching. If you found this helpful, please subscribe and hit the bell for more Maya tutorials. Thanks.